Objectives. After the completion of this module, you will thoroughly understand the following. What is a diversion canal? How do farmers benefit from diversion canals? Suitable location for constructing diversion canals. Main parts and how diversion canals are useful for the fields. Tools and implements required for construction of diversion canals. Marking procedure for construction of diversion canals. Method of constructing diversion canals. Precautionary measures to be taken while constructing diversion canals. Introduction. In the hilly and hillock areas, agriculture fields are located at the foot of the hills. The rainwater flows from hills into the fields in the rainy season. When rainwater flows excessively, there is a danger of damage to the fields which are at the foot of the hills. It is necessary to stop this rainwater flowing into the fields so as to prevent damage to the crops and also to stop this rainwater from going waste. In this kind of hilly and hillock areas, rainwater flows down and inundates. The below forms need to be controlled by constructing a diversion canal across the slope at the foot of hills and divert the stream to natural streams or the water tank or pond. These kinds of canals are called diversion canals. These diversion canals are constructed in between the foot of hills and fields. These are constructed with a specific upstream width and specific downstream width and specific depth. These diversion canals are to be merged with natural streams. The soil so dug out is used for construction of earthen bunds along the diversion canal, that is, up to where the diversion canal merges with natural stream. Merger of diversion canal into natural stream results into the increase of water level in the natural stream and pond and also increases the groundwater level in that area. Therefore, it not only avoids the runoff of rainwater from the hills, but also increases the cultivable area under the pond or natural stream. These diversion canals are constructed where the natural stream originates. Diversion canal will be constructed where field soil erodes due to runoff water. So, diversion canal diverts the runoff water and prevents the soil erosion. Benefits of diversion canals to the farmers. Now let us know the benefits diversion canals provide to the farmers. In hilly and hillock areas in rainy season, rainwater from the hills run directly into the fields. Diversion canals diverts the rainwater to the natural streams so that it can prevent crop damage and soil erosion. Diversion canals block rainwater flows into the fields. Diversion canal diverts the rainwater flow to the natural streams so that it can prevent crop damage. Merger of diversion canal into the natural stream results in improving the water level in natural stream that increases the groundwater level. Diversion canal reduces the velocity of runoff rainwater. Diversion canal diverts the runoff rainwater from places where it erodes the field soil. Suitable location for constructing diversion canals. Let us see what kind of location is suitable for constructing diversion canals. Diversion canals are constructed across the slope of the hill and between the bottom of the hills and fields. Diversion canals are constructed in hilly areas where fields are cultivated at the bottom of the hill. Diversion canals are constructed where floods from the hills cause damage to the crops at the bottom of the hills. Diversion canals are constructed on the hills where the natural streams originate. Main parts and how diversion canals are useful for the fields. Diversion canal cross-section diagram is shown on the screen. There are two main parts in the diversion canal. From bottom of the hill to the natural stream with measurements of 1.7 meters top width, 0.6 meters depth and 0.5 meters bottom width. Berm with 0.6 meters length. Earthen bund of 1.7 meters bottom width, 0.5 meters top width and 0.6 meters height along the diversion canal. Apron to prevent erosion of bottom of the diversion canal where there are deep curves in diversion canals. How diversion canals are useful for the fields. In the rainy season in the hilly areas, rainwater flows from top of the hill and reaches diversion canal. Rainwater thus reached the diversion canal converges with the natural stream. This diversion canal is constructed in between hills and fields. When the rainwater overflows above the diversion canal level, the earthen bund prevents the water inundating the fields. Tools and implements required for the construction of diversion canals. Instruments: tape, thread, lime powder,
పనిముట్లు,
crowbars, cane baskets, shovels, rammer, wooden mace. Marking procedure for construction of diversion canals. Now let us know how to go about unmarking for construction of diversion canals. Place a wooden pole where you want to construct diversion canal and mark it as X. Do all the markings in the direction towards the convergence point of natural stream with diversion canal. With the help of a tape, measure 0.25 meters from X on right side and place a wooden pole and mark this point as A1. From X, measure 0.25 meters on left side and place a wooden pole and mark it as B1. Now, join ground-driven sticks with a thread connecting from X to A1, B1. From A1, measure 0.6 meters on right side and place a wooden pole and mark it as P1. From B1, measure 0.6 meters on left side and place a wooden pole and mark it as Q1. Join A1, P1 with a thread. Join B1 and Q1 with a thread. Draw a line along the thread which tied P1, A1, X, Q1 and B1 using lime powder. This lime powder line looks like as it is shown on the screen. The distance between A1 and B1 of 0.5 meters indicates the bottom width of diversion canal. The distance between P1, Q1 of 1.7 meters indicates the top width of diversion canal. From B1, measure 30 meters towards the natural stream direction and place a wooden pole and mark it as B2. From A1, measure 30 meters towards the natural stream direction and place a wooden pole and mark it as A2. Join B1 and B2 with a thread. Join A1 and A2 with a thread. Join A2 and B2 with a thread. Draw a line along the thread which tied A1 and A2 using lime powder. Draw a line along the thread which tied B1 and B2 using lime powder. Mark with lime powder along the thread which tied A2 and B2. Distance of 0.5 meters between the middle portions of lime powder line connecting A1, B1, A2 and B2 indicates the bottom width of the diversion canal. From Q1, measure 30 meters towards the same direction and fix a wooden pole and mark it as Q2. From P1, measure 30 meters towards the same direction and fix a wooden pole and mark it as P2. Join Q1 and Q2 with a thread. Join P1 and P2 with a thread. Join A2 and P2 with a thread. Join B2 and Q2 with a thread. Draw a line along Q1 and Q2 with lime powder. Draw a line along P1 and P2 with lime powder. Draw a line along A2 and P2 with lime powder. Draw a line along B2 and Q2 with lime powder. Distance of 1.7 meters between the middle portion of lime powder lines connecting P1, Q1, Q2 and P2 indicates the top width of the diversion canal. Repeat the same procedure of marking along the length of diversion canal. This marking shall be continued till the diversion canal reaches the natural stream. Marking for berm line. From Q1, measure 0.6 meters towards the natural stream direction and fix a wooden pole and mark it as S1. From Q2, measure 0.6 meters towards the left side and fix a wooden pole and mark it as S2. Draw a line along S1 and S2 with a thread. Draw a line along S1 and S2 with lime powder. This indicates berm line. Repeat the same procedure of marking along the length of the diversion canal till diversion canal reaches the natural stream. Marking method for constructing an earthen bund. From S1, measure 1.7 meters towards the left side and fix a wooden pole and mark it as T1. From S2, measure 1.70 meters towards the left side and fix a wooden pole and mark it as T2. Join S1 and T1 with a thread. Join S2 and T2 with a thread. Join T1 and T2 with a thread. Draw a line along S1 and T1 with lime powder. Draw a line along S1 and T1 with lime powder. Draw a line along T1 and T2 with lime powder. Distance between the middle portions of the lime powder lines connecting S1, T1, T2 and S2 indicates the top width of the diversion canal. Repeat the same procedure of marking along the length of diversion canal till diversion canal reaches the natural stream. The marking of the earthen bund looks like as shown on the screen. Construction process of a diversion canal. First, let us know the construction process of a diversion canal. First, dig up to 0.6 meters depth in the middle part of A1, A2, B1 and B2, marking on all the four sides. The soil so dug out is to be deposited beyond the berm 0.6 meters, that is in the middle of S1, S2, T2 and T1. While digging, Ensure that the depth in the middle portion of A1, A2, B2 and B1 should be 0.6 meters on all the four sides. Now, dig the middle portion of P1, P2, Q2 and Q1. Then, dig the side walls along the P1 and P2 line and A1 and A2 line. Dig the side walls along the Q1, Q2 line and B1, B2 line. Trim with a crowbar for getting an even and precise slope on all the four sides. The soil so dug out should not be thrown out in the middle of S1, S2, T2 and T1, but to pave it as layers. Repeat the same procedure of digging along the length of the diversion canal till diversion canal reaches the natural stream. Wherever there are variations in the depth of the canal and at the places of sudden drop, do the pitching with 225 mm stones. The canal which is dug in this method looks like as shown on the screen. Construction method of earthen bund. As part of construction of diversion canal, now we will know the construction of an earthen bund which is below the canal and beyond the berm. As already explained, deposit the soil so dug out in layers in the middle portion of S1, S2, T2 and T1. This soil has to be layered with a thickness of 9 inches or 23 centimeters in the middle portion of S1, S2, T2 and T1. Pour water and make it firm with a rammer. If there are any soil blocks, break them with a wooden rammer. Like this, strengthen the bund with an increase of 23 centimeters layer and to construct to the height of 0.6 meters. Construct the earthen bund with a consistent top width of 0.5 meters and strengthen the slope sides with the help of templates. Repeat the same procedure of construction along the length of diversion canal for each 30 meters bit length till diversion canal reaches the natural stream. The earthen bund constructed in this method looks like as shown on the screen. Maintenance. It is important to dig the diversion canal according to the accurate measurements and make no mistakes about it and join it with natural stream. But it is also necessary to maintain the diversion canal efficiently. In rainy season, flood water from hills bring alluvial soil and deposit silt in the canal. Remove this silt as and when filled. Otherwise, this silt gets deposited in the diversion canal and water gets filled quickly and overflows into the fields. Rainwater also brings leaves, debris, rubble and dust, joins the canal and obstructs the flow. So, remove all these as and when filled. Remove any obstacles found in the diversion canal. Grow grass and plants on the bund and maintain them. Rats may dig holes in the slopes of diversion canal and these have to be filled up with sand. Precautionary measures to be taken while constructing diversion canals. The soil so dug out should not be placed on the top hill because it drains into the canal and fills the canal. The soil so dug out to be left on the berm 0.6 meters, which is below the canal. Diversion canal should not be constructed without linking to the natural stream. After digging, the diversion canal must link the canal with the natural stream. Diversion canals should not be dug without constructing an apron wherever there are deep curves in diversion canals. Wherever deep curves in diversion canals, construct apron to prevent erosion of bottom of the diversion canal. Reason: apron safeguards the bottom of the canal from soil erosion. Diversion canal should not be dug with same depth throughout the canal. Reason: if dug the same depth throughout the canal, then water will not flow but stagnate. While digging the diversion canal, dig sufficient depth according to the heights and depths of the terrain. Earthen bund should not be left without sectioning. Reason: if sectioning is not done to the earthen bund, the bund may break due to the velocity of water flow. Do sectioning for the top width and bottom width of the earthen bund. Diversion canal should not be dug on the upper side. If dug on the upper side, the canal gets filled quickly and water will overflow onto the fields. Dig the diversion canal in between the bottom of the hill and fields. Silt shouldn't be left as it is. Otherwise, this silt gets deposited in the diversion canal and water gets filled quickly and overflows into the fields. In rainy season, flood water from hills bring alluvial soil and deposit silt in the canal. Remove this silt as and when filled. Any obstacles should not be left in the diversion canals. Remove any obstacles found in the diversion canal. The earthen bund should not be left without any plantation along the canal. Grow plants along the canal so that it will act like fencing and also provides greenery. Conclusion. Now you have thoroughly understood the following. What is a diversion canal? How do farmers benefit from diversion canals? Suitable location for constructing diversion canals. Main parts and how diversion canals are useful for the fields. Tools and implements required for construction of diversion canals. Marking procedure for construction of diversion canals. Method of constructing diversion canals. Precautionary measures to be taken while constructing diversion canals.